This video will cover perpetuities in the context of recursion and financial modelling for further mathematics. A perpetuity is a special type of investment where the balance is always remaining the same. And so that means that the investment is earning interest, and that interest is equal to the payment that is being withdrawn each time period. And so if we look at this amortization table here, we can see the payment amount and the interest earned are equal to each other, which gives us a balance reduction of 0 each time period. And so that means our balance will remain constant at that initial investment amount. And so here it's not so much about using amortization tables or necessarily finance solver either, but just knowing that that is part of the definition of a perpetuity. And then also knowing that we can calculate the payment amount by using that same formula, very, very similar, or actually exactly the same as how we would calculate the interest earned in our amortization table. So it's a very useful formula to have. And so when we consider perpetuities being modelled as recurrence relations, we still do need to be able to do that. All of the components are the same as what we have seen before. So our V0, our initial amount, is that principal amount being invested. And then Vn plus 1 equals R, big R, being our rate. So 1 plus the interest rate over the compounding periods over 100, times Vn minus D, the payment amount. And a reminder that your payment amount can be calculated using your initial amount times the rate over compounding over 100. So when you're reading questions, as soon as you see the word perpetuity, you need to remember that means my balance always remains constant, and these are the key little pieces of information I need, usually that value or how you calculate that value of D. And so some common types of questions that you can be asked is actually to find what is the principal value. So maybe you are given the payment amount and you're given an interest rate and a compounding period, but you need to know how much was invested or how much do we need to invest in order to be able to earn that payment amount. And so that's where the only way to answer those questions is using that formula for D. But for other things where you need to find the value of the payment, what the interest rate was, or impacts of changing the compounding periods or different little pieces like that, you can opt for either using the formula for D or using finance solver. And so when we're using finance solver, the best way to run through it is to have your principal value and your future value. They'll be the same number, but you are investing, so negative PV, and the same number, but positive for your future value FV. And in this case, we can set N for any number of payments, but all you need to do is set N to equal 1, because we know that the balance will remain constant no matter how many payments have occurred. So our first example here, which one of the following recurrence relations could be used to model the value of a perpetuity investment, Pn, after n months? So this question, when you read it, I want you to think perpetuity means the balance has to remain constant. And so there is no quick and easy way. There is no really set of calculations that we can do to find an answer, because you notice here, each of these options have a different principal value, different initial amount. They have a different rate, and they have a different payment amount. I do need to see though that my interest is being earned. So I'm adding interest onto my investment, which means the value of big R needs to be 1 point something. So here in D and E, this would actually not be growth, but it would be decay. So we can eliminate those two options. With A, B, and C though, it really now is a matter of either calculating the value of D based on the information we have, to see if it matches the payment they've got, or the quicker and easier way is actually just to put this recurrence relation into the calculator and check that the balance remains the same. Okay, so here in a calculators page, I'm just going to check what happens when I do the first calculation for each one. So option A, I had 1.0029 times VN. So let's put in the V0 amount, $120,000, and subtract 356 as the payment. So here we can see that doesn't stay as the $120,000. We actually have a decrease there. So A is not a perpetuity. It is going to eventually run out of money. So I'll do the same thing for option B, where I had 1.0047 times, and I'll sub in my V0 this time is $180,000 and minus the payment 846. And here I can see my balance. So the next value is still $180,000. So that is equal. We'll double check and do option C as well, just to make sure. 1.0017 times my V0 amount this time, 210,000, and subtract the payment 1534. And there I get a changing value. So C is the only one there that will give me that constant balance, and that's what I need for a perpetuity. And so that gives me B as our answer there. And so sometimes in these questions there is no quicker way. So guess and check each one, but know how you can use your calculator to help you identify which one is following the properties that you need. Our next example, another multiple choice question. We have Amir invested some money in a perpetuity from which he receives a monthly payment of $525. The perpetuity pays at an annual interest rate of 4.2% paid monthly. How much money did Amir invest in the perpetuity? So what was his initial value, his V0? And so here, when you're asked to find V0, we need to utilize the formula. So our payment amount will be given as V0 times our rate over the number of compounding periods over 100. So let's set up an equation that we can solve, and then we can use our calculator to solve for us. So here our payment amount is being given to us as $525. We need to find our investment amount, V0. We're told that we have an interest rate of 4.2% and that is being paid monthly, so compounding monthly and all over 100. And so now we can solve this to find out what our initial value was. And so in our calculator, 525 equals, I'm just going to put V, and then putting in my rate, 4.2 over 12 over 100, and solving for that value of V. And I get my initial value is $150,000. And so that gives me E as my correct answer. My other option there would be to check each of the 5 options, substituting into the formula to see what the payment amount came out as. But if you know that you need to use this formula, you will always have all of the other 3 pieces of information, the D, R, and C, and then it's just solving for the initial amount. Our final example here has Julie has retired from work and receives a superannuation payment of $492,800. She decides to invest this amount in a perpetuity. She would then like to receive $887.04 each fortnight for the rest of her life. What was the annual percentage rate of interest for this perpetuity? So firstly, let's look at this and say, well, I have enough information here to be able to use Finance Solver. And so remembering that in Finance Solver, if we always let n equal 1, because it doesn't matter how long the perpetuity lasts for, we know that the PV and the FV will be the same. We're being asked to find what is the interest rate to make this true. We have a principal value we are investing, so negative 492,800. Julie is getting payments of $887.04. Her future value will stay constant at that 492,800. And these payments and compounds are happening fortnightly. So remember, a fortnight means 26 times per year. Run through and put that information in. N is 1, We're going to come back and find what the interest rate is. Our principal we put in is negative. Our payment amount, she's receiving 887.04. Our principal will be the same amount as our PV, but positive, sorry, our future value, and 26 payments per year. We come back and see that the interest rate, in order to earn that payment amount each fortnight, is 4.68%. And so our annual interest rate, 4.68% per annum. So you won't see perpetuities a lot in your exams, but it's that key thing. The balance remains the same and knowing how to use that value of D. Okay, that's it for this. Good luck.